Hello everyone. This lesson is about volumes and areas. But the key concept here are solids of revolution, which means if you have some function like this, what's the volume of this figure that's created by rotating the shaded area around an axis? So for example, the x-axis. And we'll talk about, I have some visuals here. But we're going to start out with areas of regions. So can you find the area of this region bounded by the x-axis and the graphs of y equals the natural log of x, that's this one right here, and 5 minus x, that's this guy right here, and the x-axis. So we're looking for the area of this shaded region right here. So remember that integral is the area under the curve, so we are going to use integrals. And we're going to split this into two different integrals since, if you notice right at this point, this switches from being, so this area right here, this pink area now is the area under natural log of x from, this is x equals 1, and this is the point x equals 3.69344. And you can use Desmos to find where these points intersect. That's how you find that point. And then this blue area goes from, this blue area right here is this 5 minus x curve, the area under it, from the point 3.69344 to this point when x equals 5. So we are going to find the area of this region R, which is the area of this pink region, which is the integral from x equals 1 to x equals 3.69344 of, let's see, natural log of x dx plus the integral of the blue area over here, which is the integral from 3.69344 to 5, to x equals 5 of 5 minus x dx. So you can do this by hand or use a calculator since we have a wild decimal right here. But no matter which method you use, you should get approximately 2.9858 square units is the area of that region. And that's how you find the area of a region. Just break up, so you'll use integrals, and for this one we had to break it up into two separate integrals because our functions changed at this point. So let's do another example. Oh, also, I guess I should probably explain this 2009 AB4 no calculator. These come from AP exam questions. That's where I'm getting these problems, so I thought I would cite my source and let you know that if any of you are planning on taking the AP exam in the future, these are problems that were on past exams, so congrats, you can solve AP exam problems. Okay, so for this one, we're going to find the area of R. This one is a little bit different because we don't have this bounded by the x-axis. Because remember that the definition of an integral is the area, between the curve and the x-axis. So that means, kind of make it lighter. So the area under, let's see, we got y equals 2x. I guess I'll label these. So that means this guy is y equals 2x. And maybe I'll use a color that's not so obviously the same. Let's see, in this darker black curve, if you can tell the difference, the curved one is y equals x squared. Okay, so let's take a look at the area under y equals 2x. So the integral from 0 to 2 of 2x is this whole shaded region. Oh, I'm going to cover up that line, aren't I? Alright, we can do this. This whole region right here, and this whole region outside here. You get the gist here. So that's the area under this y equals 2x curve. We want the area between these two curves, so like just this little purple area right here. So if we just find the area under the curve y equals 2x, we get that area, but we get all this extra area too. But take a look at this. The area under this curve, this y equals x squared curve, is all of this area, which is the part of our pink integral that we don't want to be part of our solution. So if we take the integral of 2x from 0 to 2 and subtract this area, this purple area, from which is the integral of x squared from 0 to 2, then that'll get us the area of our region here. So this means we're going to take the area, which is an integral, so the integral from 0 to 2 of, let's see, 2x minus x squared dx. That'll get us just this area between these two functions. In other words, it's this top function minus the function underneath of it. Okay, so we'll do this one by hand just for the practice. So let's see, integral of 2x is x squared minus, let's see, this is going to be, the integral of x squared is going to be x cubed, and then multiply it by the reciprocal of the new exponent, so 1/3 x cubed. And we need to evaluate this from 0 to 2. Let's see, 2 squared is 4, minus 1/3, 2 cubed is 8, minus, plug in 0, that one's 0, that one's 0, so this whole thing is going to be 0, minus 0. Alright, so let's see, this is equal to 8 over 3, so let's see, 4 is equal to 12 over 3, minus 8 over 3, which is 4/3 square units, is the area of this the region between these two functions. That's the area of the region between those two functions. And these are two examples, but that's the gist of finding areas of regions. And that's it for this video. So email me if you have any questions at all about this.